Okay, so this is the third and final video for chapter 9.2. So we've done step 1, which was determine the limiting and excess reactants. We did step 2, which was determine the theoretical yield of unknown. So last part, what do we do with that theoretical yield? So first off, definition. Theoretical yield is the maximum amount of product that can be produced given a certain amount of reactant, specifically the limiting reactant, because it limits the reaction, it limits how much product is made. Okay, so that's what you solved for. After you determine the limiting reactant, you take that known, you solve for the unknown, you find the theoretical yield of unknown product. Okay, then you can also have, or you will also have, an actual yield. An actual yield is the actual measured amount of product obtained. So you actually do the reaction. How much did you actually get from experimental, not just mathematical? Okay, and then you compare the two. So as I said before, this is a real life application. Chemists are interested in how efficient a reaction is. So if you want to get your maximum amount of product, you need to know how much reactant to use. But you also don't want to waste reactant. So for example, say you need 10 grams of product, okay? If 5 grams of a certain reactant will get you to that 10 grams, then you only need to use 5 grams. But if you need 10 grams, you don't want to use 4 grams, then you wouldn't get what you need. You also don't want to use 20 grams and have a huge excess of reactant, or I'm sorry, excess of product if you only need 10 grams. Okay, so this is all about manufacturing. When they're making products, shampoo, food dye, whatever it may be, they have to know their starting amount and their ending. It's just like cooking. If you want to bake a cake, you know you need 2 eggs. That's what directions tell you. To get the cake and the result you want, you have to use 2 eggs. Okay, you can't use 1, and you don't want to use 3. It's the same idea with chemistry. So the comparison is called percent yield. You can either do a percent sign and Y, or just PY to abbreviate. I usually do PY, actual yield AY, theoretical yield TY, but whatever you want. It's actual over theoretical times 100. So you're going to get a percentage. Okay, so 3 examples and then you'll be done. But like I said, if you actually try these and you follow along, then you should be good to go. Okay, so pause, balance first. It looks a lot harder than it is. Did anyone notice that it's already balanced? Yeah, don't make it harder on you. Okay, step 1, balance it. I already wrote it for you. All right, so this is going to be a little bit easier because I'm already telling you that this is my limiting. Okay, I'm telling you that in the problem. So let me move this out of my way. This is my excess. I'm telling you that to make our lives easier, so cross that out. Okay, I want to know if I have 36 grams of C6H6 reacting with whatever amount of chlorine. I don't care because it's my excess right now. How much of this product will I get? Okay, so it's just a mass to mass stoich. My known is given to me. It's my limiting. I would make you solve for that, which I will in a minute, but I just want to move along so you see how this works. So I'm still doing mass to mass stoich, and some people are like, oh, this is so much writing. It is a lot of writing, but it's not hard and it's repetitive. So could always be worse. And mole ratio is 1/1. And then my unknown molar mass. Okay, plug that through your calculator, and I get about 53 grams of C6H5Cl. something close to that. Okay, this is my theoretical yield. In the problem, I'm giving you the actual yield. It's right here, and I have to tell you that. The actual yield is that. So now you just use the equation for percent yield, actual over theoretical times 100. So percent yield is actual over theoretical at, if you like to remember it that way, times 100. So I take my actual, don't forget a unit, over my theoretical times 100. You're not doing 100% sign in your calculator, just 100. Okay, and I get about 73.18. What's my unit for percent yield? The percent sign, because grams cancels out grams. Okay, so I am 73% yield with this reaction. So what this means is my theoretical yield that I calculated was 53 grams. When I actually did this problem, or did this reaction in the lab, I only got this much. Okay, so if you're trying to get 53 grams, you're gonna have to adjust. Maybe there was, it's not so much adjust the reactants, maybe the process of collection isn't as great as it could be. Maybe you need to do a gas collection. Maybe you need to find a different means because scraping it off the side of the flask is not, you're losing an amount there, whatever it may be. Okay, so step one, I shouldn't say step one, sorry. Step one was LRER. Step two is theoretical yield. Step three is percent yield. Lots of writing. The good news is I can only give you a couple problems then because they're so long. If you can do one, you can do many. Okay. Try this one. Some of you are still struggling with writing out equations. You have to check charges unless it's a prefix compound. You have to look for diatomic elements and then balance it. Some of you are not doing that and it's just causing a headache. So go ahead and write that out, balance it, and then we'll try it. Okay, so calcium has a +2 charge. Chlorine has a -1. So I have to crisscross them, and this 2 comes down here. Plus ammonium, not ammonia, NH4, which is a +1. Hydroxide, -1. If you want to put that in parentheses, you can. 2 radicals. Yields, calcium, +2. Hydroxide's a -1. Have to crisscross it, so that 2 comes down here. Plus ammonium chloride. Okay, so if you're balancing it, you can leave your radicals whole. I would say that's the easiest, but that's up to you. Easy fix, I'm going to put 2 here. It gives me 2. Put a 2 here. That fixes that, and that fixes that. So my balancing answer is 1, 2, 1, 2. Okay, if you want to write that up here so you have it in case you need a better visual. I just like when you do that so it's easy for me to find. Sometimes I can't read your writing up here. Okay, so that's done. So let me clean this up. You don't have to clean it up either. I want to see your charges. That counts as like work. I only do it so I have more room to write. Okay, so now that I've written and balanced it correctly, I can actually start chapter 9, specifically 9.2. Okay, so step 1 is determine the limiting and the excess reactants. So I only care about those reactants. So I'm going to start with calcium chloride, but you can start with whatever you want. My unknown is the reactant I didn't start with. If you have more than 2 reactants, you're only comparing the ones I gave you numbers for. So that's all the complex. Oh, we're not going to get more complex than that. Okay, my unknown is 35. Remember, you don't take it times this 2. It's just 35. Just N plus H plus H plus H plus H plus O plus H. And then 1 mole on the bottom, always. Okay, so if you do it that way, I get that I need 63.6 grams of NH4OH. If you do it the other way, you would get, so if you started with NH4OH, ammonium hydroxide, you would get that you need 96.4 grams. Whoops, that's not right. Let me run this through my calculator. And remember, guys, you only have to do that one way for limiting and excess, unless you want to check yourself. I also didn't put my number out here. How dare I? 100 grams. And I like 2 decimals. So when you're rounding, just give me 2. Okay, if you did it the other way, if you started with 100 grams of NH4OH, you would get that you need 157.14 grams of calcium chloride. Okay, so I need 157. I only have 100, so that looks like calcium chloride is going to be my limiting. I need 64 grams. I have 100. It looks like ammonium hydroxide is going to be my excess. Doesn't matter which way you do it. Okay, so this was step 1. All right, step 2 is to then use the limiting to determine my unknown theoretical product. I'll go for blue just to make it easier to see. Okay, so I can cross this out. And it says, calculate the theoretical yield of ammonium chloride. That's this. So also, you don't really care about this. So you can cross that out if you want to. You should only ever be comparing 2 things, no matter what step you're on. All right, so I've got 100 grams calcium chloride. And remember, I don't have to redo the math because it's right here. All right, mole ratio is going to be 2 moles of ammonium chloride, because that's my unknown, over 1 mole calcium chloride. And then my unknown molar mass, N plus H plus H plus H plus Cl, is 53. Remember, it's Cl, not Ci. Also, don't take it times the coefficient of 2. Coefficient is only used in the mole ratio. Okay, plug that in your calculator, solve. It's okay if your numbers are slightly different than mine based on rounding. I get 96 grams of my unknown. Okay, that is my theoretical yield. So that's step 2. Finally, step 3. Can't underline it, there we go. Step 3, I take my percent yield equation and I do my actual, which is right here. And the problem, I have to give it to you. Actual over, and then let me write because I'm so close to the bottom. Theoretical times 100, and I get 99.12%. That is my percent yield. That is a full chapter 9.2 problem. A lot of writing, not that hard though. Think of it that way. Could be a lot of writing and be super challenging. So this tells me that this is a good reaction because I'm getting very close to the amount that I theoretically calculated I would get, which is awesome. That's what you're looking for, especially if you're in the lab making stuff. All right, last problem. So step 1, balance it, I guess, or step 0, because you're always doing that. Step 1, limiting an excess. Step 2, theoretical yield of unknown. Step 3, percent yield. So write this down, actually try it out, come back. I will tell you that this is not as bad as it looks. You can leave your radicals whole. All right, so balancing, you should have got 1, 3, 2, 3. Okay, you can start with iron sulfate or lead chlorate, whichever. Step 1 is LRER. If you're thinking, why are we doing so much math? Welcome to Chem 2. Lots of algebra, lots of math. Okay, my mole ratio is 3/1 because I'm only comparing the reactants. Make sure you have a unit and a label on everything and make sure those are correct or it's half a point off. And then my unknown molar mass. Okay, so if you started that way, you should get about 207 grams. And that's what you need. If you did it the other way, if you started with PbCl 032, you would get, let me do it in my calculator, 17.9. Okay. Doesn't matter which way you do it. Don't have to do it both ways unless you want to. Okay, I need 207 grams. I only have 50. This is going to be my limiting according to the first one. That means my FeSO4 with subscripts will be my excess. Check it this way. I need 17.9 grams of iron sulfate. I have 74. That checks out. Okay, so that's step 1. Limiting an excess. Step 2 is to take my limiting and solve for theoretical. So I'm going to cross that out. Here's my unknown that I care about. I don't care about this. Start with your limiting. And some people are always worried, well, what if I get it wrong? What if I mixed up the limiting and the excess on a test and then step 2 and 3 are wrong? Well, yeah, that's unfortunately a possibility. So if you want to on a test, maybe do it both ways. You should get the same answer. If you do it both ways and you get conflicting answers, you know something's wrong, then you can go back and carefully look it over. Because you're right, if you get part 1 wrong, step 1 wrong, you're going to get step 2 wrong and step 3 wrong. Unless you're lucky. Oops. Mole ratio is the only place I use my coefficients. So when I find the molar mass of my unknown, I'm just doing Fe plus 3 chlorine plus 9 oxygen. Do not take that whole thing times 2. And please make sure I can read your work and find your answers. Okay, plugging that through your calculator, I get about 27.26 grams of my unknown. That, you don't have to like write it, but you can if you want. That is my, whoops, I'm writing a P. That is my theoretical yield. Use the limiting. I just put YT. Oh my gosh, it is only Monday. Now I am losing. I know it's not Monday for you guys, but it's Monday for me. T, theoretical yield. And on most of your worksheets, I do have lines for you to write these on, so it's easier for me to find. Okay, step 3 is to actually find my percent yield. So percent yield is actual yield given to you in the problem by me over theoretical yield that you solved for times 100. So going back in the problem, here's my actual yield. I have to give it to you. With a unit, you don't have to put a label unless you want to. My actual yield, or I'm sorry, my theoretical yield. And I get my percent yield to be about 98.9. Once again, that's an awesome result experimentally. Okay, I will say, not trying to trick you, it is possible that you get over 100%. It's not actually feasible, but mathematically you could get over 100%. So if your number on top is bigger than your number on the bottom, you will get a number over 100. You're not wrong in your calculations. Okay, so that is it. Chapter 9.2, step 1, step 2, and now step 3.